Hello everyone. Here I'd like to present you the iTech IT2800 series of high-precision source measure unit, also called SMU. We will use it to test the forward conduction curve of a silicon carbide diode. Before the test, let's take a look at the appearance of the IT2800 SMU. First, it has a 5-inch touch screen. The biggest highlight of this product is its graphical display, which supports 3 modes: scope view, record view, and graph view. In semiconductor testing, it is usually necessary to observe the 4-characteristic curve of the diode, and the function will make the testing easier. Let's look at it from the scope view mode. Under this mode, the sampling rate of the SMU can reach up to 10 microseconds, which is equivalent to the function of a basic oscilloscope. Now, we enter the setting interface to set the trigger edge type. You can choose to trigger on the rising or falling edge. At the same time, you can set the trigger level on the user interface. You can input the specific trigger level or complete the setting by moving the trigger baseline up and down. The scope function is very useful to capture transient signals. Next, we are talking about the record view mode. What is the highest sampling rate allowed? We might as well input a very small numerical value and we can see that the fastest sampling rate is 100 microseconds. The IT2800 series SMU provides a large buffer capacity, which allows users to continuously collect 1 million data points at the fastest sampling rate of 100 microseconds. After the test is completed, the recorded data can be exported to an external USB removable memory for analysis. Of course, through the record view of IT2800, you can also easily observe the data fluctuations during a long-term testing. Next, we will demonstrate the sweep and graph view display function for you. You can choose different curve display modes such as UI or IU or reverse mode. Of course, you can also select the data list to view the detailed data during the testing. The sweep function of the IT2800 supports various modes, including linear sweep, logarithmic sweep, and list custom sweep. The editing process is very user-friendly, and you can import test files from an external USB removable memory. In addition, you can also create new files and edit sweep curves directly in the interface. Furthermore, the sweeping direction supports both single and double modes. In silicon carbide diode testing, we select the linear single mode and set the starting and ending voltage for the sweeping. Here we set the ending voltage to be approximately 1.8 volt. During the testing, you may have specific requirements for the step voltage. You can directly change the step voltage or adjust the sweeping points. The system will automatically match the correct scan point number and step parameters for you. Here I set the sweeping from 100 mV to 1.8 volt with 101 steps. Each step lasts for 100 milliseconds. You can also choose curve display on a logarithmic or linear scale. I have chosen the linear scale. Now that we have completed the voltage sweep settings, it is ready to test the 4-curve of the silicon carbide diode. First, turn on the output, then providing a trigger signal. Now, you can see that the SMU has acquired the 4-curve. If the curve is not centered in the screen, you can click the Auto button to make the curve display in a more appropriate position. Meanwhile, in order to facilitate users to view the numerical value of any point on the for curve, IT2800 provides the data cursor function. After enabling this function, a red cursor line can be seen on the UI. You can manually move the cursor position, but this may not be precise enough. So you can also use the knob to move the cursor line. For example, in the datasheet of silicon carbide diode, the forward voltage of the diode is specified when if is 1 ampere. By using the cursor line function, moving the cursor line to the position of 1 ampere and measuring the forward voltage, the reading is 1.563 volt. You can see that the entire test is very convenient and you can save the process of exporting data for further analysis. That's all for today's sharing. Thanks for watching.
iTech, your power testing solution.